Perfect. And we can get started. Thank you, Jim, for the introduction. It's great to be back here. Yeah, it's always that time of the year we look forward to coming back here. So yeah, today we are going to present on our GenAI on-call co-pilot journey, how we built it, what all things we went through. And we have Nicholas and Edwards with me as well. All right, so this is how pictorially a day of an on-call looks in Uber, and pretty much I would imagine in most tech companies where there is so many different changes happening. Even a small config change can cause an outage, and then there is so many different platform. Like for example, Michelangelo is the ML platform in Uber, and there's so many different components in the platform that can change underneath, and that can cause issues to the customers. So an on-call really has to fight a lot of fires, look at incidents, look at incoming customer issues, and there is like too much to deal with in a day. Yeah. So from a user perspective, the users of platforms like Michelangelo and other platforms, the problem is like users are wanting to develop some products on top of these platforms, and they have to navigate through a bunch of complexity, and they need help from on-call, but then the on-call is busy doing so many things. So there is a lot of loss of productivity in that sense for the users of these platforms, since they have to wait, and pretty much there is so much domain knowledge that only the on-calls have, that the users might not be able to troubleshoot issues on their own. Other thing that we also find in Uber, which I would imagine is also generally applicable to most tech companies, is that information which is relevant to what a customer wants is generally spread out in many different data sources. It's like NGBkeys, Jiras, and Slack, and Google Docs, and like any other information in slides. This is like all spread out in so many different tools, and there is no one easy way to find out, okay, for a given problem, where to go and look for actual answer. So yeah, we had all these pain points at Uber, and that's where we thought like having a GenAI on-call co-pilot should make life easier. But then as we were thinking about building it, we also saw many challenges for it. So here are some of these. With any GenAI solution, the LLM is there in the picture, but then the response accuracy, the hallucination is always a challenge to deal with. So that challenge actually leads to, there is some sort of bias, at least we observed in humans, that our users feel more comfortable when the on-call responds the same answer that the bot would respond. So there is some credibility issue as a bot, even though it responds right. Somehow the human beings feel like, okay, we need more human support in the loop. So there's that issue. Also, building a very clean UX experience, specifically, we'll show it later. I mean, it's a difficult thing to knock down, because users expect a lot of features from the bot specifically, and somehow their bar for the bot is always higher than humans. Also, with the LLMs in picture, there are so many third-party LLMs coming into the market, and ensuring or using judgment of which data is okay to be sent to the LLM, that's like requires a lot of judgment. So that's a difficult problem. And then curating which data sources actually have good information, that also requires a lot more work than what we anticipate generally. Yeah. So I'll just show you what we have built, and then I'll pass it over to Nicholas and Edwards. So here is just a quick glimpse of what we have built. So like here, example, Edwards is asking a question on one of our Slack channels, and Genie, our on-call co-pilot, is answering that, okay, what is Michelangelo? Michelangelo is Uber's internal machine learning platform. It's also giving references of where it got the answer from, and then is also giving users ability to give feedback on how the bot did. So idea is that we use this feedback to basically make sure the answer quality can keep improving. That's the whole ecosystem we built. So in general, our objectives are, we want to collect feedback. We want to provide really relevant information with sources, so that It improves the credibility of the information is not hallucinated. And in general, as you can see here, the user doesn't have to wait for the on-call to respond. It's pretty much instantaneous response, which improves the life of the user and productivity of the whole engineering ecosystem. Yeah. Over to you, Edwards. Over to you, Nicholas, rather. Yeah.
Thanks, Parth. So now I'll talk a little bit about the high-level architecture, and then we'll dive a little bit into each of the components. So at the highest level, our platform architecture provides a zero code solution for managing generative AI chatbots. So all the customers need to do is specify their data sources and integration points through configuration, and our platform does the rest. One of the most common use cases here is for teams to leverage chatbots to answer questions, as we discussed, which they had already documented in their wikis. Take our team Michelangelo as an example. We may receive a question such as how to train a model, and these steps are clearly laid out in the existing documentation. So all our team had to do was configure Genie, telling it which data sources and wiki to use for our help desk channel. And that's why first and foremost, the platform provides two primary APIs, one data ETL to regularly refresh your data, and two, the chatbot APIs, which integrates with LLMs to provide the quick answers from your data. So creating a POC with all these tools, like in a Python notebook, is one thing, but productionizing a platform has a lot more baggage, which is why we also cover evaluation and cost tracking in our solution. These additional features help users understand and address issues in data quality. And as we know, bad data in and bad answers out. And then with GenAI usage quickly becoming one of the highest ticket items on budgets, cost tracking is a must. Next slide, please. So first we'll talk a little more about data ETL. Here our goal was to make it as easy as possible to integrate customer-specific data from the most common data sources. That's why we brought this experience directly into Michelangelo Studio's UI. You can see on the right side what it looks like to integrate a specific data source. On the top right, you can see how to set up a wiki, where you just need to provide the wiki spaces that contain the relevant pages. For example, on this slide, the user provided the Go monorepo space and the Go framework space. Below that, you can see how to configure a Slack data source, providing the relevant tags. And then on the bottom right for files, you can just drag and drop them directly into the page. And then their corresponding blob store file paths are displayed for reference to the user. And then here on the left side, you can see kind of end to end what it looks like. Customer would enter in like the name for the pipeline, select the multiple data sources where they want to write the data to, such as a Hive table or to a vector database. Next slide, please. So now let's take a look a little more closely at how the data ETL runs step by step and some of the customizations we allow. So we start with a daily pipeline trigger, which kicks off the process. Then the pipeline consists of three major steps. First, data prep, then chunking and embedding, and finally pushing to external systems such as Hive or a vector database. In the first step, data prep, the pipeline pulls data according to the user's configuration. With semantic search, one of the easiest ways to improve accuracy is to narrow down the scope and difficulty of the problem. As such, we usually recommend users provide only data which is directly related to their problem. Otherwise, noise in the data could degrade accuracy. The second step is data transformations, both chunking and embedding. We have default chunkers based on the data sources and file types, but any custom chunking can be added as well. For embedding, we offer two primary methods, first being proprietary API calls such as OpenAI, which many customers use as the default, and second, open source models. We've seen open source models, they've proven to be accurate and cost effective, particularly for higher scale use cases. These models are hosted in Michelangelo and can be used for the latency sensitive online serving cases, as well as batch high throughput offline pipelines like this one. Finally, we come to the pusher step. Here we integrate with vector databases as well as offline storage systems. Offline storage systems give us the ability to easily inspect and reuse the data. You can use regular SQL tools to debug and analyze the data. Also, if the upload to the vector database fails, it provides the ability to retry uploads without rerunning the entire pipeline. After being persisted offline, the data is then written to an online vector database where it can be used for online serving. Now I'll hand it over to Edwards for the rest. Thanks.
Thank you. So yeah, this is the overview of the platform, how we manage to receive the question and then eventually respond to the question. So it all starts pretty much with the user posting a question. And in our case, it's mostly Slack. It also can be ID or maybe something else eventually. And then this question is eventually posted to knowledge base service. And this knowledge base service has three steps: embedding generation, context retrieval, and answer generation. And the first embedding generation, we have to make sure that we use the same embedding model which we used in data ETL. Then as soon as we retrieve the vector of the embedding of the question, we pass it to the context retrieval. There we use either similarity searches or any other searches to find the most relevant context. And that context we pass to the answer generation. There we add prompt, ask LLM. Again, it could be open source, self-hosted, or OpenAI or any other proprietary model. And then eventually the answer from the LLM is given back to the client. And there are three main features which makes this platform interesting. First is we managed to include cost tracking in the platform. So how it works is that when the customer asks a question and then this user experience or Slack channel, for example, it also passes the ID of a Slack channel, and which is kind of ID of a customer. And that ID is then propagated to all the LLM calls in the logs. And then these logs eventually can be parsed. And then from that, we can make a dashboards and then we can attribute the cost, who and how much spent on the calls. Another thing what we wanted to make sure is that we allow customers to have custom prompts because everyone has their own prompts and they think that one is better, one is worse. So in the answer generation step, we actually call key value database where a customer can manually keep their custom prompt, and that prompt will be retrieved in the answer generation step and added to the prompt, and then eventually given to the LLM. And in this demo slide, you saw that it also give the citations. And to enable the citations, first of all, when we did context retrieval, we make sure that we keep the link and we pair it with the chunk, and then we pass it to answer generation. We build a prompt such way that we pair the link and the chunk together, and then in a prompt itself, we also want to make sure that LM returns what is link, what is the source of the context which you used. And yeah, it works pretty well. Next slide, please. And then, yeah, like when you put it to production, then you obviously need to have evaluation to make sure that it works well. And this is another extra pipeline which runs. And then for that, it also starts pretty much that we retrieve the data from Hive tables. We retrieve logs. And the logs is pretty much where we keep the question, answers, and the context. We use user feedback from the Slack. And then, yeah, because we don't want to run this evaluation on good answers, we want to make sure, like, we want to understand why, when it's wrong, why it's wrong. And sometimes we also use some extra metadata to eventually group the results. And all this data is passed to the feature prep. And feature prep, the data is retrieved, joined, cleaned, and then it passes to evaluator. And evaluator runs on every question answer pair, and there are two ways to go with it. Like one is classical NLP metrics, like blue score or something else, and then we can again use LLM as a judge. And what we find interesting in this case is that we were asking like for a coverage, we were asking, is this question sufficiently covered in the documentation? And if it's not, can you please provide suggestions how we can improve the documentation? And then from that evaluator, we pass it to the aggregator, because typically everyone wants to know like general metrics. And then if it's a numerical, we calculate the mean and whatnot. And then if it's textual outputs from LLM as a judge, then we ask another LLM to summarize all the suggestions. And then eventually we put it to evaluation report, which is the UI for Michelangelo. Next slide, please. And this is the UI of Michelangelo. So here you can see that the bottom there was on the question level, you have a coverage score question response parts, and then you can see all the context and whatnot. And you can go through by question level, and then at the top you can see the total summary of the report, how it sums up and gives the general suggestion for everything. And then next slide, please. And so far we enrolled the Genie on more than 150 channels. We answered more than 70,000 questions, and in half of the cases, customers found it helpful. So there's still quite enough to improve. But but anyway, we calculated that we saved almost 13,000 engineering hours, and so far, it's like pretty much one of the main conclusion is that it's easy to demo like any GenAI application, but when you go to production, then it's always hard. But it is also very important to use to work with the customers, so we can gather the feedback and then improve on our side. And Genie started as one of the first use cases in Uber as a RAG, but then we built all this infrastructure, and now we enable a lot of other use cases to utilize this infrastructure for their own custom RAG applications. Next slide. So thank you for your attention. Then we recently published the blog about Genie, so you can follow the link and pretty much read more about it.